Go. Good afternoon, everyone. This is Barb Tyson, and I'd like to welcome you to another Salty Dog webinar. I'd like to start off by thanking Chris Parker of Marine Weather Center for sharing his time and knowledge with us today. And before we get started, a couple of reminders. We would appreciate if you would keep muted and your video off. I have opened a chat box where you can type in any questions that you have for Chris. And finally, we're recording this webinar, and I'll send out a link as soon as we have it uploaded. That way you're going to be able to review all the great info from Chris. And a couple people have asked me, so I just want to mention that you can watch the recordings anytime and as many times as you want. So let's get started with today's webinar, Passage Making in the Caribbean, Weather Considerations, presented by Marine Weather Center. And with that, I'll hand things over to you, Chris.
Terrific. Thanks, Barb. Good afternoon, everyone. And if you have any questions, feel free to type them in the chat box, and we'll answer some as we go along and maybe have a little Q&A at the end as well. So in our previous webinars this fall, we have talked about strategies for getting to the Caribbean, so I'm not going to spend very much time on that. But a little bit of a review of large-scale synoptic weather will set the stage for talking about what drives weather in the Caribbean. And today we'll talk about large-scale drivers of weather in the Caribbean, as well as small-scale phenomena that happens around islands and land masses that will influence weather in the Caribbean, and how you can take that into account when you're sailing. We'll also talk about some strategies about where you might want to go to from the East Caribbean once you arrive. You know, where you might go for, say, tropical season next year or what have you. So large-scale wind is driven by pressure gradient. That is simply the pressure difference over distance. And what is important on this slide is really just that there's a relationship between the tightness of the packing of the isobars and the wind. So obviously that is a wind flag that is south or maybe a little south-southwest at 40 knots. There are 1, 2, 3, 4 full feathers. That's 40 knots. This is west-southwest at 35 knots, 3 full feathers and a half a feather. And that's 50 knots, a filled-in triangle. Notice that where we have areas of low pressure, the isobars, the barometric pressure gradient, is tightly packed around the area of low pressure, and that's where we have most of the wind. In areas where we have high pressure, in the middle of the area of high pressure, there's very little wind. And as we move away from the area of high pressure, the wind starts to speed up, and it gets going faster and faster and faster until it approaches the area of low pressure, and then it slows down. The sweet spot for sailing may be really close to the area of high pressure if you want lighter wind, or further away from the area of high pressure if you want stronger wind. And this plays a part sometimes in the trade winds in the Caribbean, as we'll talk about today. This is another way to envision the wind gradient and the pressure gradient associated with high pressure systems. So think of a car on top of a hill. The car is parked at the top of the hill. It's not moving. The parking brake is on. And on the synoptic chart, we would be right in the middle of the area of high pressure. As we start moving away from the area of high pressure, start moving down the hill, the car is going to start to roll. Well, how is it going to roll? It's going to roll slowly at first, right? And then as the slope of the hill becomes steeper, and as the car gradually overcomes inertia, it will gain speed. And as long as the slope of the hill is fairly steep, the car is going to keep gaining speed faster and faster and faster. And that's exactly what happens with the wind as we move away from an area of high pressure. As we relax the pressure gradient, as the isobars spread out a little bit, in the middle of the area of low pressure, we actually often get an area of lighter wind. So let's look at the zones of weather. And we talked about this in some of the previous webinars, but we're just going to review it here quickly. We have cold polar air way up north. Then we have the upper latitudes where migratory low pressure systems and cold fronts pass with rather nasty and clement weather. In the subtropics, we have persistent ridging of high pressure, and that would be a clockwise flow around the area of high pressure in the northern hemisphere. And then down in the tropics, there is a semi-permanent area of low pressure toward the equator. And this is a convergence between the air flowing from the southeast toward the northwest from the southern hemisphere, and from the northeast toward the southwest in the northern hemisphere. So the trade winds that are coming from Europe are blowing from Portugal and Gibraltar and the Canaries down into the tropics, and then westward across the tropics into the Caribbean, and westward through Central America often, and into the Pacific. This is another way to envision the mean annual average winds around the globe. This is our scale over here to the right. This is in meters per second. So anything in white is below 2 meters per second on an annual average basis, so very light wind. And the color scale goes up from yellows to greens to blues to purples. And what we see here is in the Caribbean, we tend to be in the strongest winds on a mean annual average basis in the whole northern hemisphere in the Atlantic. And these are the northeast winds coming from Europe, which generally become more east-northeast or east as they approach the Caribbean. And then there's often some light wind along Central America, and the trade winds kick back in again as we move out into the Pacific. So this area of light wind near 30 degrees north on a mean annual average basis is the subtropical high pressure ridge. Now, sometimes that lifts north a little bit, sometimes it moves south a little bit, sometimes it's stronger, weaker. This winter, it seems that we have a La Nina winter, and in a La Nina winter, we typically get stronger high pressure a little further north in the waters, quite often south or southeast of the Canadian Maritimes, well south of Greenland, kind of between Bermuda and the Azores. And this can set up a large blocking ridge of high pressure that drives unusually strong trade winds in the Caribbean for extended periods of time. So, you know, it's not a guarantee, and I'm sure we'll get some breaks from it. But typically in a La Nina year, we will tend to have relatively stronger than normal trade winds it's at different points during the winter. Now, it doesn't necessarily always happen at the same time. I remember in 2005, quite clearly, it was 2005, I believe it was 2005, was a remarkable year. We had in the month of May, it was basically the last 3 weeks of May and the first week of June. There was a really big blocking high pressure ridge in the Northwest Atlantic. And this drove gale or near gale force wind for 4 weeks nonstop from the northern Bahamas to Panama. The whole of the Bahamas, the whole of the Caribbean. We had winds 50, 60, 65 knots off of Colombia. And it was just amazing winds for 4 weeks, unbroken. We actually had clients in the Abacos who, and elsewhere as well, who had insurance expiring, and they needed to contact their insurance companies to get riders so that they could stay where they were until the weather conditions became acceptable, because in the Abacos, for instance, all of the cuts were impassable. It was dangerous. The vessels couldn't go out, and they were out of time to get back to the U.S. before hurricane season. So, but they, it was rage conditions with gale force wind. So this doesn't necessarily happen just in winter. It can happen anytime. It can happen even in the spring, even in the late spring. But we would expect to see at least some intervals of wind that are slightly above normal this winter. Now, that doesn't mean the whole winter is going to be that way, but on an average basis, I'll bet we're slightly above normal on trade winds. So getting to the Caribbean, we go through 3 zones of weather. The first zone leaving the United States is typically where in the upper latitudes where the low pressure systems and cold fronts are passing, and there's very changeable and often inclement weather. In the middle zone around the subtropical high pressure ridge, the cold fronts move into that area, kind of stall, linger, eventually weaken, and hopefully dissipate. And then we're left with relatively light wind until the next approaching cold front. So that tends to be in the area along the subtropical high pressure ridge, which we see here. I've got in this example centered somewhat east of Bermuda. Then south of the ridge, we tend to get trade winds that may start out somewhat east or southeast in direction, depending on where the center of the ridge is. Notice that if we lie on the southeast side of the ridge, we get east-northeasterly trade winds. If we lie on the southwest side of the ridge, we get east-southeasterly trade winds. So the east-west position of the center of the ridge makes a difference in the direction of our trade winds. And this would happen in the Caribbean as well, although to a slightly lesser extent because we're further away from the high pressure ridge. So here we've got pretty much straight easterly trade winds in the Caribbean with the ridge sitting to the north-northeast of us. But look at the wind direction out here in the tropical Atlantic. On the south side of the ridge, the wind direction is east-northeast. So in wintertime, typically, the ridge of high pressure is a little further west. And the trade wind direction in the Caribbean in the wintertime tends to be east-northeast. In the summer, the Azores Ridge sets up, the Azores-Bermuda Ridge, the Azores-Bermuda High, and the mean position of that is a little further east. So in summer, we tend to have east to east-southeasterly trade winds in the Caribbean. This can be a little frustrating if you're, let's say, in the Virgin Islands and looking to go south and east toward Trinidad or Grenada in June, because at that time of year, we've got the Azores-Bermuda Ridge set up. We tend to get east-southeasterly trade winds, which is a really foul direction. So we need to wait for a break in those east-southeasterly trade winds before we can move east and south toward Grenada or Trinidad. Conversely, let's say that we're in Grenada or Trinidad and it's December and we decide that, hurricane season's over and it's time to go north. Well, now the ridge mean position is further west, so the trade winds are east-northeast. So it's kind of upwind again. So we want to wait for the winds to be easterly rather than substantially north of east in order to make our way north from Trinidad or Grenada. So just keep that in mind that sometimes the trade winds are a little contrary to what you want to do if you're trying to move north and south along the island chain. For anyone who is maybe going to miss the Salty Dog flotilla in early November, let's say that you plan to do it, but something happens and you're late, or maybe you plan to just go on your own later on in the winter. There are certainly good options for heading south anytime during the winter. Now, if we're in one of those periods where we've got a really strong area of high pressure to the north, maybe we've got a few weeks or a month where the weather is just horrible and you're not going to go. But if you're willing to be patient, we can find windows from the US coast to the Caribbean any time of the year, even in the middle of winter. Typically going from New England is going to be really difficult. It takes a very, very many days in the wintertime to get south of the areas of low pressure and cold fronts and into the ridge of high pressure where the weather is not as bad, and then, into the trade winds south of that. And the windows are really, really short in the wintertime. So it's unlikely that you'll be able to leave from New England anytime in December or even in November. It can be really tough leaving from New England in November. Leaving from Hampton, Virginia, it also becomes more challenging as fall wears on, because we've got maybe 36 hours before we're across the Gulf Stream and into what's typically the area where we've got high pressure ridging, or at least where the cold fronts are a little weaker and we've got a lot of sea room to deal with them. But if you're leaving out of, say, Beaufort, North Carolina, then we've got some more options. You're really close to the Gulf Stream. You can be across and south and east of the Gulf Stream in 18 hours instead of maybe 36 leaving out of Hampton. And you're also a little further south, and you're not having to, round Hatteras. You're going through the Gulf Stream where it's maybe a little bit weaker, and southwest of Hatteras. So especially if you're not leaving in early November, I would kind of gravitate toward departing from Beaufort. Now, we got a lot of folks saying, well, I'll just keep going down the coast until I get a good window to go to the East Caribbean. But the problem is that once you head south and west of Beaufort to Southport, to Charleston, to Savannah, Brunswick, you've got to make all that easting up before you get into the trade winds. So typically, if you go to Charleston or Savannah or Brunswick on the way to the Caribbean, you're going to cross back right over your path, except in the Gulf Stream versus just north of the Gulf Stream. But you're essentially going to retrace the same route eastbound into the waters a little bit south and east of Hatteras before you turn south. Stand by just a second. Hello, this is Chris. Hello? Hello, this is Chris. Hey, Art, I'm in the middle of a webcast. Can I give you a call back in about an hour? Okay, not a problem. Okay, yep, bye-bye. So consider that if you're planning on going south and east along the coast. Let's say that you're heading down to the Bahamas and eventually to the Caribbean. We can do that any time of year. Chances are that from Florida, you'll head essentially east, maybe a little bit east-northeast. And the only difference is that the further south and east you get in the Bahamas, the more of a northeastward trajectory you're likely to have to do on your exit from the Bahamas toward the Caribbean. So you kind of converge on the same point regardless where you leave from. So there's no problem with going further south and east. It does cut off a few miles, but we get a lot of folks who just have trouble mentally, leaving the Turks and Caicos and sailing northeast toward Bermuda because they're not sailing toward the Caribbean, at least initially. But we just have to reinforce that the easiest way for them to get to the East Caribbean is to initially head toward Bermuda and then head toward the Caribbean when the time is appropriate. And, we'll guide you through all that. But that's counterintuitive and really frustrating for a lot of folks. So let's say that you're in the Caribbean and now is time to head home or wherever else you are going to go. When is the appropriate time to head home? If you want light wind and are willing to do extensive motoring, there are usually really good opportunities in April and May. There can be intervals of strong wind. That's the change of seasons. Generally in the Caribbean, and I guess we'll get to this in a moment, but I'll give you a little preview now. You've heard the saying that March comes in like a lion and goes out like a lamb. Well, typically in the Caribbean, that's true. We get stronger wintertime trade winds into the early part of March. But as we get into the latter part of March, we start transitioning into a spring pattern where we have lighter trade winds and usually milder seas. And as we go through April and May, we can still get, the weather's changeable. We can still get really strong conditions, but we also get intervals where there's just no wind for, days or even weeks at a time, where the winds are really, really light, even in the Caribbean, but especially north of the Caribbean. If you actually want more wind for sailing, I would suggest leaving the Caribbean for the United States not until June or even July. We typically don't have much in the way of tropical weather in June or even most of July. The Cape Verde season, where systems develop off of Africa, move toward the Caribbean or the West Atlantic, that doesn't really ramp up usually until sometime in August. And any tropical low pressure systems we see in June and July typically are going to form along a frontal boundary that stalls somewhere in the Atlantic waters north of the Caribbean, or in the West Caribbean or the Gulf of Mexico or the Bahamas area, or off the US East Coast. And so, as long as, and those can happen in April and May as well. So as long as insurance company doesn't, force you to make decisions otherwise, if it were me, I would wait until June or July to head from the Caribbean back to the US. In addition to leaving out of the north part of the Caribbean, we can leave out of the south part of the Caribbean and go west. There are a number of good hurricane holes. The best place to go is where hurricanes don't go. And the next place to go is where hurricanes are weak and or you can get well inland. So hurricanes tend to be weaker toward the equator. The hurricane needs the spin of Earth in order to induce the spin in the hurricane. And that Coriolis effect, where the spin in the Earth causes the wind to rotate, that doesn't happen around the equator. So we need to get up to 6, 7, 8, 9, 10 degrees north latitude before we start inducing enough spin to develop any sort of a tropical low. And those tend to be weaker at the latitude of, say, Trinidad, and tend to be almost non-existent down toward Guyana. Now, the further north we get, the stronger the hurricanes can become. And in, 2005, we had Ivan. Was it 2004 or 2005? We had Ivan in Grenada. And that was, a Category 5 hurricane in Grenada. There have been hurricanes in Trinidad. So lying south around 10 or 12 north is not guaranteed to keep you safe from tropical systems. But typically in Trinidad, we're not going to get a really strong hurricane. But, if you wanted to be completely safe, then you would go down to Guyana, where you're really south of the hurricane belt. The ABCs are another option. Some folks go to Bonaire, Curacao, or Aruba. That's certainly a possibility. There are wind reversals in the ABCs, and we can get hurricanes. I would say that the ABCs is probably about as safe as Trinidad. So it's certainly a viable option, but it's not a guarantee. On the other hand, as we get down to Santa Marta and Cartagena in Colombia, especially Cartagena in Colombia, in order for now with a hurricane, we need to understand the distribution of wind around a hurricane. And typically all of the really strong wind is going to be in the right front quadrant. And that's the area where the storm motion adds to the wind speed. And it's also the area that's called the dangerous semicircle, where if you're caught in that area, you can't really sail out of it. The wind traps you in that dangerous semicircle until it spits you out the other side. So in order for the right front quadrant to hit Cartagena, the hurricane would have to be moving south or southeast. And I'm not saying that can't happen, but it would be just a freakish occurrence. So it's highly unlikely that we would get any sort of a significant hurricane in Cartagena. In Panama, likewise, in order for the right front quadrant to get us in Panama, the hurricane would have to be moving south, or pretty close to south. And now we're south of 10 degrees north latitude, so we don't have a lot of spin in the atmosphere either. So we would, any hurricane that might freakishly hit Panama probably wouldn't be very strong. Other good options would be the Rio Dulce. Now, certainly the Rio Dulce is in an area where we can get hurricanes, even strong ones. But you're up a narrow river with a delta at the bottom that's very shallow, and steep banks on the river and lots of trees around, and so you're reasonably well protected from tropical systems. So the Rio Dulce would be a really good place to be if you're going to be in the hurricane zone. Another good place to be would be Luperon in the Dominican Republic. Again, situated on the north coast of the Dominican Republic, a hurricane would have to be moving southwest or south to get to Luperon, and that's not a typical wind direction. Again, it's the right front quadrant of the hurricane that we're really concerned about. The left front quadrant, the winds are less strong, and if the system is moving from east to west along the north coast of the Dominican Republic, it will probably have been weakened some by interaction with land before it gets to Luperon. Same thing with Cuba. If you are permitted by your government, then places like Varadero and Havana, Cuba are good places in a hurricane, even Puerto de Vita. So anywhere on the north coast of Cuba, in order for the right front quadrant to get you, the hurricane has to be moving south or southwest, or as I guess it was Irma did, kind of stall right along the coast, and could inflict some significant damage that way. But if I were picking a hurricane hole and in the hurricane zone, the Luperon area, the western part of the Dominican Republic on the north coast, or the north coast of Cuba would be good places to consider. Green Cove Springs in Florida. Florida is concave, so in order for the right front quadrant of the hurricane to get the North Florida area, the hurricane would have to be moving basically west and not somewhat northwest. As it was moving northwest, the right front quadrant wouldn't intersect the coast until maybe Georgia or South Carolina. And you're 30 miles inland, so the system would have had some chance to weaken before it gets to you. So not a guarantee, but if I had to pick a spot along the US East Coast, anywhere south of Hatteras, I would probably pick the Green Cove Springs area well up the St. John River. So that's a little discussion about what you might want to be thinking about after your winter in the Caribbean. So what's the weather like in the Caribbean? We do have seasons. There's hurricane season. Hurricane season is generally has the highest risk in the East Caribbean from August 1st through October 15th. And this is the typical Cape Verde season where tropical waves are coming off of Africa, migrating westward, and potentially developing into strong hurricanes. That has come to a close for this summer. It came to a close about 2 weeks ago, so a little bit early. So that's a good thing. We're quite relieved. We think that the East Caribbean has probably dodged the bullet of any tropical low coming across the Atlantic waters. Now, that's not to say something couldn't develop in the Caribbean and impact the any part of the East Caribbean, and that can happen any time of the year. I previously thought, until I did a little more research, that we had not had a tropical low in the Northern Hemisphere in the Atlantic in the month of February. But there was one. It was about 100 years ago. And in February it was sometime in the late teens, so 1915 to 1920, somewhere in there, a tropical low formed along a stalled cold front northeast of the Caribbean and migrated southwestward into the Caribbean. And it was a significant, I think, a Category 2 or Category 3 hurricane in February in the Caribbean. So just because we're out of tropical season doesn't mean that we can completely ignore the weather and not check the weather for weeks at a time, because something like that can happen. It's very unusual, but it can happen. There is some risk of tropical activity in the Caribbean anytime from, let's say, May through the end of December. If you're outside of that, January, February, March, April, the odds of anything tropical in the Atlantic, in the East Caribbean, really, really small. November, December is changeable weather. We tend to get moderate east-northeast to east trades, seas, and maybe a few residual tropical waves coming in from the Atlantic, bringing in some significant squall activity. Late December into March is our winter time. We tend to get steadier east-northeast to east trades, larger seas, some periods of northerly swell. We tend to not get a lot of thunderstorms or other convective weather, but we can still see little upper level disturbances that cause the typical overnight into morning squalls to be more significant. And make a point to talk about that in a moment. In April and May, we tend to get lighter east to east southeasterly trade winds. And in June, July, stronger east to southeasterly trade winds. Seas also tend to pick up a little bit, and we get into a cycle with tropical waves where it's going to be northeast for a day as a wave approaches, then the wave passes and it shifts to the southeast and it's squally for a day. Then on the third day, we tend to get gradual improvement. The fourth day is a pleasant day with wind backing from the east to the northeast. And the fifth day would be also the first day of the next cycle where we get northeast winds. So what you would want to do if you were moving south and east in, let's say, June and July, is out of every 4 or 5 day cycle, you would get 1 or 2 days that are decent for moving when that wind is backing from the east to the northeast and arriving someplace before the tropical wave comes in with the nasty squally weather. And obviously we want to keep our eyes out for any hurricanes. So what if you're in the Bahamas? What if your plans are to go to the Bahamas? Oh, and I see we do have a couple of questions. So Helen, when would I advise leaving the Caribbean heading toward the Azores? Stand by a second. Hello, this is Chris. Hello? Hello? Hello, George, it's Chris. Yeah, I'm on a webcast. Could you call back after 6 o'clock? Yes. Okay, yep. So when is a good time to leave the Caribbean, head toward the Azores? As early as April. And typically the earlier in the season you are, the more you're going to want to sail a direct sort of a run line route toward the Azores and not get all the way up toward Bermuda. On the other hand, you can do it as late as June. So I would leave the Caribbean anytime from basically April 1st to maybe mid-June. Anytime in there is probably just fine. If you want to spend more time in the Azores or more time in Northern Europe before fall comes around, then I would probably gravitate toward the early part of that window, leaving sometime in April, maybe early April. And if you want the lightest wind and maybe not spend so much time in the Azores, or if you wanted to go to Bermuda, then I would probably leave sometime in May or even early June. Andrew, local weather systems that develop during the winter, i.e. squalls. Yes, so we are going to get into that. So give me just a minute there. So let's say that you plan to spend some time in the Bahamas. What are the seasons in the Bahamas? The hurricane season, a little different in timing in the Bahamas. Season maybe is a little longer. We've got risk not just from the Cape Verde season, but also from systems developing in and around the area and along cold fronts. More risk than in the East Caribbean. So the greatest risk would be maybe August 1st to October 30, but there's some risk anytime from May through December. The weather is really changeable in November and December with some cold fronts, some hurricanes. So again, it's really changeable. Late December into early March, we tend to get more and stronger cold fronts, especially in the Abacos, and it's much cooler. But it's more consistent weather in terms of there being regular cold fronts. So that makes the weather really changeable, but it's in a predictable pattern. So we get into this pattern with cold fronts. Late March to May, it's still changeable, but we've got fewer and weaker cold fronts. We get more and longer intervals of light wind. There can be some hurricanes as we get into May, and there tends to be an increase in convective thunderstorms as we get into May and June as well. Something the northbound Salty Dog certainly found last May in the Bahamas. That was really foul. June to October, we get intervals of light wind along the ridge, but there's also generally an east-southeast to southeasterly flow in areas south of the ridge, which covers most of the Bahamas. And there's some convective squalls and thunderstorms and some hurricanes. In the Bahamas, we can kind of break things down into a couple of zones. In the northern Bahamas, in January to March, it may be too cold for swimming. There is a lot of cool weather. The cold fronts are really strong. If I were looking to go to the northern Bahamas, I would pick a time maybe in April, May, and June, where it's a little warmer. There are not as many cold fronts. The water is actually warm enough for swimming. October to December are also good months, and hurricane risk is maybe May to December. In the central Bahamas, January to early March is also cool. It's not usually really cold though, but it may be kind of cool for swimming. We do get strong cold fronts here, although there are some intervals of mild weather. And I'd say March and April are probably nicest. As we get into later April and May, it gets really buggy sometimes. So you may find that March is a really nice month where we don't have as many and as strong cold fronts as we had earlier in the winter, but there's still enough of a trade wind flow to keep the bugs at bay most of the time and to give us a nice little breeze at anchor. In the southeast Bahamas, we tend to get fewer and weaker cold fronts, but there's also less protection from cold fronts. So the best months vary, but you're going to want to maintain a very careful weather eye in the southeast Bahamas, because getting all around protection for wind from any direction is really difficult in the southeast Bahamas. A little bit about the West Caribbean. Generally, we only have hurricanes north of Panama, very few hurricanes around Panama and Colombia. Greatest risk for hurricanes would be August 1st through November 30. So the season lasts a little longer because of cold fronts coming into the West Caribbean and stalling in the fall. And there may indeed be some risk through the end of December with those stalling cold fronts. December to April in the West Caribbean can be relatively dry, but also rough with strong trade winds and big seas in late December through April. So May through November is generally milder wind conditions, but as we get into late May and June, Panama gets really, really wet with the intertropical convergence zone. So if I were transiting in the West Caribbean, probably the months I would pick would be April in the spring, and it could be March, April, May in the spring, and then kind of November, December in the fall, or at least November and the first half of December in the fall. But that period of time from late December through at least early March can be really kind of nasty. So everything that we've discussed previously has been relative to gradient wind. And I want to draw a distinction between three types of wind that we often see. The gradient wind, which is driven by high pressure, which is up near maybe 30 degrees north on average. Sometimes it's up more toward 40 north, but the high pressure ridge may often be around 30 north. And the lower pressure that tends to be toward the equator. So that pressure gradient supports wind. And so the driver of that wind is a pressure drop over distance, air flowing from high to low pressure. because of the Coriolis effect. It can't flow directly from high to low. It flows in a circular fashion outward from high pressure and inward toward low pressure. But basically, this is a horizontal wind. It happens over a really large synoptic scale, 1,000 miles or more between pressure systems. It's really steady wind. So the direction and the speed of the wind tends to be really steady. The predictability is very high. Forecast models do a really good job of forecasting the gradient wind. Surface effects, we tend to see steady sustained winds, maybe plus or minus 20% in gusts, and it's really persistent. As long as the pressure gradient persists, the wind is going to persist without a whole lot of change. But then we have convective wind, and convective wind is driven by thermal differences within an air mass. Specifically, parcels of air which are warmer than the air mass surrounding it rise, and other parcels which are cooler than the surrounding air mass fall. So we get the vertical motion of air up and down in the atmosphere. And this transports a lot of energy up and down in the atmosphere as well. The scale of these convective winds is small, anywhere from maybe tens of feet to a few miles, but the predisposition can be over hundreds of miles. The variability, it causes wind speed and direction to vary considerably. Prediction confidence, forecast models do a really poor job of forecasting the convective wind. Now, we can use some guides like lifted index or really CAPE is a better estimate. And some of the forecast models, particularly the mesoscale models, the shorter range, higher resolution models, which unfortunately aren't run for the Caribbean, can provide a lot of insight to what the convective wind potential is. Global forecast models don't tend to do a great job with that, but we can use the estimates from global models along with knowledge of the underlying dynamics of the atmosphere to arrive at an educated guess about what the wind may do in squalls. And the surface effects are going to be significant speed and or direction changes in wind. These changes are very intermittent and periodic, lasting from seconds to minutes, but the predisposition for convection may last for hours. Persistence, briefly for individual cells, but again, the predisposition can last for hours or days in a general area. So we'll talk a little bit more in a few minutes about convective winds, but that's what we're talking about when we talk about convective winds. And then finally, there are boundary layer winds. And this sounds really complicated. Someone's got their mic on. So if you can check your mic and make sure you don't have your mic on, that would be great. Then we have the third type of wind is boundary layer winds. And this sounds really complicated, but it's really not. So the driver is disuniformities driven by non-atmospheric phenomena. An example would be friction differences between land and water. So there are a lot of trees and buildings and hills over land that adds friction and it slows down the wind speed. There's very little friction over water. The only friction over water is the waves. So the wind tends to blow a lot faster over water. So there's a boundary layer that happens at the lower levels of the atmosphere where the air intersects with the ground. And there's a difference in boundary layer conditions between what you have with air interfacing with ground and air interfacing with water. So it's a difference in the boundary layer conditions that causes a weather event. We can have that with a differential in temperatures as well. Maybe we've got a cool land and warm water, or vice versa, a warm land and cool water. Where the air comes in contact with those different temperatures, there's a different reaction to that. And where we have the change from water to land, then the weather can happen in that space. The direction can vary depending on the disuniformity. It can be more vertical or more horizontal. The scale is anywhere from, and again, it's proportional to whatever's causing it, but it can be from a few feet to 100 miles or so. The variability, this tends to be fairly persistent, sometimes repeating in a diurnal pattern. and it tends to not vary a whole lot. So the variability reflects the disuniformity, but as long as the disuniformity isn't changing, things are not very changeable, if that makes sense. Prediction confidence. Forecast models do a reasonably good job today of dealing with boundary layer conditions, except in really small scales. So the resolution of global computer models is maybe 5 or 10 or 15 kilometers. And if we get any weather event that's happening on a scale that's smaller than 1 or 2 times that resolution, so let's say that we're dealing with a forecast model that's got 13 kilometer or let's say 8-mile resolution. Any weather event to be picked up properly would have to be picked up similarly in at least 2 adjacent forecast boxes. So we would need to have the weather event happening uniformly over an area of maybe 16 miles with an 8-mile resolution to our forecast model. So you can see that winds around islands and around coastlines may not be properly reflected. Now the models try to, to deal with that limitation. Some of them do with varying amounts of success. So just realize that if you're in an area where conditions are changing at the surface, you're going from warm to cool or no friction to friction, or where something else in the terms of the surface topography is changing, that may have ramifications on the weather. Okay. So this is a sea breeze convection cycle, and we'll just run through this real quick. And so let's say that we are going down to the beach on a hot summer day, and it's 8 o'clock in the morning. We park the car in the parking lot and walk out to the beach and set up our beach umbrella and start reading a book. So 11 o'clock rolls around, and now I'm thirsty for a beer, and I notice the bar down the beach is selling Kalik beer, and it's been a while since I've had a Kalik beer in the Bahamas, so I really have a hankering for that beer. So, but I left my wallet in the car, so I got to walk back to the car and get my wallet. Well, guess what? I left my shoes in the car too, because I hate shoes. So as I walk across the sand at 11 o'clock in the morning, now the sand is hot beneath my feet. But I get to the parking lot, and you know how with asphalt, oftentimes the asphalt gets really old and the gravel starts getting loose, and they come along and put a fresh application of black tar on the asphalt to bring it back to life again, so that you don't have loose gravel on it. And so they've just done that to the parking lot. So it's got this fresh blacktop on the parking lot. And when my feet hit that at 11 o'clock in the morning with the sun beating down on it all morning, the soles of my feet are just about burned off, and I'm running across the parking lot to get to my car before I get blisters on my feet. So what do you think happens to the air that is immediately over that hot parking lot? That air gets heated up dramatically, and the air over the parking lot is substantially warmer than the air in the grass fields surrounding the parking lot or the beach. Excuse me. So warm air rises. Those parcels of air over the parking lot are going to rise, and they're going to displace air that was over top of the parking lot. Well, some of that air gets displaced inland, but as more and more air rises, even the air over the fields and the grasses is going to start rising during the day. It's generally buoyant over land during the day. So eventually, the air that's rising from the parking lot is going to be forced out over the ocean. And or it's going to force out the air that was in the atmosphere above it over the ocean. And that air is going to force downward the air that was over the ocean. And then, nature abhors a vacuum. So the air parcels that are rising from the parking lot, air has to come in and be replaced, to replace that air from some direction. And if the air is generally buoyant over land, the only place for the air to come from is the sea surface. So we get this sucking motion during the day of air from the sea surface toward the beach and toward the parking lot to replace the air that lifted upward out of those areas. So this tends to be a self-reinforcing sea breeze convection cycle. It usually peaks in the late afternoon, and then in the evening it'll shut down, and at night often we get the reverse. We get a land breeze at night with air coming, moving down over the land where it's a cool surface, often cooler than the sea surface at night, because the sea surface remains virtually unchanged in temperature day and night. And then air moving from the beaches and parking lots out into the ocean at the surface at night, and actually rising, particularly in the Gulf Stream off of Florida and the US East Coast at night. And so our convection source at night is the warm waters. Now, in the Caribbean, this happens as well. So I actually don't think I brought the slides along that, that discuss this, but I don't really have any great graphics for it anyway. So just discussing it is good. The same thing as that land breeze at night in the Gulf Stream happens in the Caribbean at night. So this answers Andrew Armstrong's question. In, let's say, the Chesapeake Bay over land areas, we're used to thinking about getting thunderstorms in the afternoons and evenings, right? The sun heats up the land heats up the air rises over the land, we get convection and rising air in the afternoon, and then in the late afternoon, typically, we get thunderstorms and everything comes crashing down. In the tropical environment, tropical marine environment, it's exactly the opposite. What we get typically are squalls and thunderstorms that occur late at night into the early morning. And one of the explanations for that is that the effect is that same land breeze effect, where we get cool air sinking over the land, because the land cools down more at night than the sea surface. And then the air moves from the land out into the sea, and because the sea surface is warmer, the air starts rising over the sea surface. So the convection mechanism in the tropics, in the marine tropics, is nighttime convection, partly as a result of a land breeze. The other thing is that, let's say we have, go back to the principle of warm air rising over the parking lot during the day. The parcels of air over that hot black asphalt parking lot are probably 100, 110, 115 degrees, and the surrounding air mass is maybe 85 or 90 degrees. So as long as those parcels of air are warmer than the surrounding air mass, they're going to keep rising. Now, everything cools down as it rises. You know, the pressure on the gas lessens as we go up in the atmosphere. And as the parcel of air expands, it cools. That's one of the properties of a gas. So all of the air is going to cool generally as we move up in the atmosphere. But as long as those parcels of air are warmer than the surrounding atmosphere, they're going to keep rising. So what also happens in the tropics is, and I'm going to give you a couple of figures. Let's say that during the day, the sea surface temperature is 80 degrees Fahrenheit, and the surrounding atmosphere is 80 degrees Fahrenheit. And at 2,000 feet, maybe the atmosphere is still 75 degrees Fahrenheit. That's a pretty stable atmosphere. It's going to be really difficult for air parcels to rise from the surface if all of the temperatures are fairly uniform at the surface and if the temperature doesn't fall much as we gain altitude. So again, during the day, we may have a situation where we're 80 degrees at the sea surface, we're 80 degrees ambient air temperature near the surface, and we're maybe 75 degrees at a couple of thousand feet up in the atmosphere. But at night, what happens? At night, the sea surface stays 80 degrees Fahrenheit. The ambient air temperature around the sea surface is maybe, 78 or 79 degrees Fahrenheit. It stays fairly close to the sea surface temperature. But now as we go up in the atmosphere, it gets much cooler. We're away from that warming influence of the water, and maybe the air at 2,000 feet altitude is down near 65 or 70 degrees Fahrenheit. Well, now any parcels of air that do start rising encounter cooler air surrounding them. And now they're warmer than the surrounding environment and they can keep rising. So we tend to get more convective support at night in the tropics because the surrounding air mass cools down while the water stays warm. So that's interesting. So typically, at night in the tropics, we will get squalls and not usually thunderstorms, because there's not usually that much convection unless there's some sort of a disturbance in the area. We'll tend to get squalls maybe between about 4 in the morning and about 9 in the morning, and then they'll be pretty much done. Now, on a typical night, those squalls may only pack wind of 3, 4, 5 knots above the gradient wind. So if the forecast is for 15 knots of wind, gusting to 20, maybe it'll be 20 gusting 25 for a few minutes when one of those little squalls passes. But something we often see is that when we have stronger gradient winds, we often have some sort of a weather feature that's causing that, a little trough in the atmosphere. And that trough may also help to support a little bit of lifting, maybe a mechanical lifting, like a wind direction change that forces air up in the atmosphere because of collisions of air molecules. So that provides a little bit of additional support for the lifting of air. So let's say that we've got a little bit of a weak trough in the East Caribbean, and that because of that trough, the gradient wind is now 25 knots instead of 15. So again, in the first example, we had 15 gusting 20 with a few squalls between 4 and 9 in the morning that were 20 gusting 25. Well, now let's change that to 25 knots of sustained wind because of a little trough in the area, and maybe gusting to 30. But now we've got more convective support, and maybe we've got 35 or 40 knot squalls. So that's a whole different kettle of fish, isn't it? I'm okay with 15 knots, gusting 20, and an occasional 20 or 25 knot squall. That's not so bad. But if I add 10 knots of wind to the gradient wind, and I get up to 25 knots, now I got gusts to 30 and squalls to 35 or 40 because there's more support for convection. And 35 or 40 is a whole heck of a lot of wind. So rule of thumb, when I'm in the Caribbean, really I want to keep trade winds under 20. That tends to keep the effects between the islands reasonable as well. If I'm going to be transiting between large mountainous islands, I may want to keep the winds even less than that. Let's talk a little bit about why that is here in just a second. So this is, of course, the island of Puerto Rico. And during the daytime, we get air moving up over the mountains, upslope wind over the warming mountains, rising air, that sucks wind in from both directions. So the easterly trade winds tend to be somewhat northeast on the north coast and somewhat southeast on the south coast, with the air blowing inland and up the mountains. And at night, conversely, we get a wind coming down off of the mountains, and that downslope wind typically blows from the land into the marine areas, and this gives us calming conditions at night. So although the easterly trade winds are still blowing strong, and even I would argue stronger at night than in the day because of that diurnal convection pattern we talked about, typically the trade winds are stronger at night in the Caribbean than they are during the day because of that. Along large mountainous islands, we will typically get much calmer conditions at night because the air is blowing down off the mountains. And even though sometimes it's a strong wind, there's not a lot of fetch, and it usually doesn't cause any real big seas. So remember what I said about sometimes it's not strong, sometimes it is strong coming off the mountains. That's going to be important in a few minutes. So what is this? This is, you know, I'm a boater. Everything has to be, has to have dual purposes. So this is Florida. It's Puerto Rico turned 90 degrees. It's Florida. This is the Panhandle. These are the Florida Keys. You know, same thing would happen with the wind pattern adjacent to Florida. If we had a southerly wind, then during the day, there would be a southeast wind on the East Coast and a southwest wind on the West Coast with air converging toward the land. And at night, it would be the opposite. We would get air coming off the land into marine areas off of Florida in a land breeze. So a little bit of a tip, air tends to parallel coasts, and it tends to be stronger than the gradient wind forecast due in part to funneling and less friction over water. And these are some examples: Southeast US coast, Florida, Dominican Republic, Cuba, Colombia. You know, it happens everywhere we get an interface between land and sea due to that friction difference. I don't want to spend too much time on this example. But this is an example of a gradient wind forecast. This is the GFS model on the left, and on the right is the ASCAT satellite wind data showing what actually happened. And what's important with this passing cold front is that the computer model predicted that we would get a gradual shifting of wind across the cold front from west-southwest ahead of the front to west, then northwest, then north, then northeast behind the front. And that isn't what happened. What happened was there was an inflection point right along the front. This is just a snapshot at 2:49 UTC in the morning. So this is about 10 o'clock at night. And what happened was you can see an inflection point right here, right off of Charleston, South Carolina, where the wind on one side of the front was out of the west-southwest, and on the other side of the front was out of the east-northeast. 180-degree wind shift across the front. It didn't veer gradually. It flipped 180 degrees like that. The reason is that coastal effect, that wind paralleling the land. The wind really didn't want to be, anything other than parallel land one way or parallel to land the other way. In order to find wind that wasn't parallel to the land, we have to go maybe 60 or 100 miles offshore. Now we get the gradual wind veering that the computer model predicted. Here's another example of why this happens. Think of if you are an airplane pilot. Let's say that you're flying along at altitude, at cruise speed, and you've got a relatively flat wing. If you are on a sailboat, let's say that you are on a really, really close reach and you have the sails in, really, really tight because you're on a really, really close reach. So let's say that now on the airplane, we're coming in for a landing. And when we come in for a landing, we want to slow down, but we also don't want to come crashing out of the sky uncontrollably. So when we slow down, we need more lift in order to counteract, gravity. So we put more shape in the wing. On a sailboat sail, if you want to go fastest when you're on a reach on a sailboat, you're going to do what? You're going to let the sheet out and let it out and let it out. And as soon as it starts to luff a little bit, you're just going to pull it in just a little bit. So you've put as much shape as you possibly can into the sail, as much curvature as you possibly can without it creating a luffing effect. So that's creating the most work. It's bending the most amount of air that it can possibly bend without the air becoming detached. The key is, does the air stay attached to the wing? As long as it does, the wing operates very efficiently, the sail operates efficiently, and we're all good. But let's say that we do something to turbulate the flow and separate the flow from the wing. Maybe we've let the sail too far out and it starts to luff. Maybe when the airplane comes in for landing, we deploy a spoiler and that turbulates the air away from the wing. Now the lift is gone, the sailboat doesn't go anymore, the plane does come crashing out of the sky, but if we're 2 feet above the ground, that's what we want to happen. So now the airflow is separated from the land. But realize that the air is going to try to remain attached to the land as much as it possibly can until it encounters something where it just cannot stay attached to the land, and then it separates from the land and there's a turbulent flow. What does the west coast of Cuba look like? Does that look like an airplane wing or what? It's like it was just purpose made for this purpose. So along the north coast of Cuba, with an easterly trade wind pattern, we will get winds backing to the east-northeast as we move from Havana toward the western part of Cuba until we get just west of 84 West, right in this little nook here. And notice how the land all of a sudden cuts back in on itself. When it does, that creates a turbulence. The air separates away from the land, and there's a little rotor in here, and we typically get really, really light winds. So maybe offshore, the flow can kind of stay attached to itself, but we really lose the effect of air paralleling the land as we get out toward the western tip of Cuba because of that little turbulating effect there. So how far offshore does this go? There's a high pressure ridge in the northeast Gulf of Mexico, just south of Apalachicola, Destin area. And the air west of Florida wants to be northeast or east-northeast, and not, and you know, in this area along, let's say between 84 and 85 West, it wants to be a little east-southeast as we get away from the ridge of high pressure, and it wants to be more southeast and southerly as we get out into the Gulf. But notice the wind direction in here around 25 north is east-southeast. Well, what happens as we approach Cuba? It backs to the east near 24 north, and then the east-northeast as we approach the coast of Cuba. So the wind direction is definitely paralleling the coast to some extent, as much as maybe 100 miles offshore, and to a greater extent as we get within maybe 60 miles of the coast, very much parallel to the land. What is this wind here? Why? Well, let's look first at the southwest coast of Cuba. All of the air molecules that attach to the land and curve along the north coast of Cuba, those air molecules are moving really fast in, if you will, a high pressure area. And the, or maybe it's a low pressure area, but they're moving really fast. And the air molecules on the other side of Cuba are moving really, really slowly. So why then do we have these really strong winds in this area on the south coast of Cuba? Well, those are the nighttime katabatic winds coming down off the mountains. And on the south coast of Cuba, we tend to get a really pronounced diurnal pattern where it starts blowing really strong all of a sudden in the evening, and then it shuts down during the day. And then it starts blowing really strong all of a sudden in the evening, and it shuts down gradually during the day. So we may talk more about that in a few minutes. So that just summarizes that when North Cuba tends to parallel the coast and often does so a little stronger than the computer models predict. So a little more about what happens around islands. Let's say that this is Dominica or Martinique or St. Lucia or any of the larger, more mountainous islands in the East Caribbean. On the windward side of the island, we have sailboat heeled over, whitecaps, and air flows up the mountain on the windward side. That air is compressed, it's blowing really, really fast, and sometimes there's a mechanical lifting that lifts the air up so high that it cools, and it condenses out water vapor into water droplets and forms clouds. So sometimes we get a mechanical cooling of the air or a mechanical lifting that results in a cooling of the air, and that will trigger clouds over the islands. Those clouds then drift downwind. So on the backside of the mountain island, we may see a rotor where we get really, really light wind or even wind from the wrong direction a little bit. But at night, this flow often reverses itself. And at night, sometimes the air that's coming up the mountain remains attached to the land, because, you know, it's obviously attached to the land as it's moving up the mountain. Well, sometimes at night, especially, the air coming down the mountain's backside remains attached to the land. And now this air is cooler and more dense than the surrounding air mass, and it sinks really, really fast. And this katabatic downslope wind is often given names, local names, depending on where it happens. The Mistrals and the Maltemes in the Mediterranean, Willowa winds in Panama, they call it the Chocosana winds, and may also be referred to as the Papagayo winds. In Nicaragua, they're called the gap winds, where air blows through the gap in the mountains of Nicaragua. And it's downslope wind into the valleys from the mountains, and then it funnels out into the sea. So this can be a really strong effect. Off the coast of Colombia, we can almost double the wind speed at night. So if we've got a 25 knot gradient wind, we can end up with 50 knots at night. Oftentimes, islands in the East Caribbean and elsewhere, even in the Bahamas, clouds can mark the islands during the day. And that condensing of the visible water vapor into water droplets forms clouds due to convection and or mechanical lifting. And you can actually navigate by that. So if you were without GPS or without compass and forced to navigate that way, you can often find your way along the islands just by looking up at the sky and seeing where the clouds are, realizing the clouds are going to form along the islands and then drift downwind, whatever downwind is. So typically, if you find a cloud and you look under that cloud or upwind from that cloud, that's where the island is. Let's say that we're in an anchorage and it's 7 o'clock in the morning and the weather forecast was for the wind to be 15 knots today and it's flat calm. Is the forecast wrong? Well, I mean, obviously it's wrong right now, but I would argue that there's a pretty good chance the forecast is going to be correct. What has probably happened is there's a little bit of an inversion, a little bit of a protective dome effect. And that thermal inversion can keep the gradient wind out from the areas real close to the surface. And this happens especially in early mornings and especially near or over land. But it's only in the very bottom layer of the atmosphere, maybe the lower few hundred feet or 1,000 feet or so of the atmosphere. And as soon as the air mixes vertically, as soon as the sun comes up and heats the atmosphere a little bit and we get that vertical mixing that happens with the sun's energy, that breaks up this protective dome effect and we'll get the full trade winds. So if it's 7 in the morning and it's flat calm and it's supposed to be blowing east of 15, give it a couple hours. By 9 or 10 o'clock in the morning, I almost guarantee you it's going to be blowing east of 15. We could talk a little bit about waves. I don't want to spend too much time on the height, direction, and steepness causing shoaling, but just realize that if we get seas that are coming in from deep water, if we get gradual shoaling, it dissipates the energy gradually, so we don't get breaking waves. But if we get rapid shoaling, now we get large breaking waves. And in the gradual situation, the wave energy is dissipated over a very large area and it's a very gradual dissipation of energy and it won't have any, really bad effects. But in this scenario where we get rapid shoaling of the sea bottom, of the water depth, we can get a rapid discharge of energy from waves and dangerous breaking surf. So if you are entering, if you're in deep water and entering shallow water, it's usually better to do it gradually rather than all at once, unless you've got some sort of a breakwater or some sort of other protection to, to break that chain of events. One thing we talk about sometimes is fetch. I just wanted to define fetch a little bit. That's the distance between you and the shoreline in the upwind direction. So it takes time for wind to build seas. And if the air is blowing from the land and we are, 500 feet from the land, then there's only 500 feet of fetch for the wind to impart energy into the sea surface to develop seas. So we're not going to get much of a wave action in 500 feet. But let's say that we're a couple of miles from the beach. Well, now there's a couple of miles that the wind has had to develop seas. And let's say that we're 100 miles from the beach. Well, now there's 100 miles. There's a long time, maybe hours and hours that the wind has been blowing over the water, and it's developed pretty large, mature seas. So just realize that if you want to reduce wave action, oftentimes you're going to want to snuggle up close to the land that is in the direction where the wind is coming from. So oftentimes we're asked by folks in the East Caribbean for much more specific wind forecasts. Let's say we're traveling from Dominica to St. Lucia and it's going to be a long day. And we want to know what the wind speed and direction is every minute of the day between Dominica and St. Lucia. Well, it's virtually impossible to tell you because the wind speed and direction are going to change every inch of the way because the topography of land that you're behind changes. When you're behind a big mountain, the air is going to go around or over the mountain. It may or may not come down the backside. It may rotor. When you're adjacent to a big mountain, the wind may bend around the mountain. When you're near the south coast, let's say that this is an area where we're moving from Martinique. Let's say this is the south end of Martinique Island, and this is the north end of St. Lucia. As we approach the south end of Martinique, we're moving down the backside of the island in the lee of the land. Wind is going to be really, really light behind the island of Martinique. We'll probably motor sailing or motoring with very little wind. But as we approach the southern tip of Martinique, we're going to get wind kind of on the nose out of the southeast that picks up from maybe 10 to 15 to 20 knots. Even if the gradient wind is only 15, this wind here near the southeast or southwest tip of Martinique may be 20, and it may be southeast instead of east. So it's kind of on the nose and it's stronger than it was supposed to be. We get out into the middle of the passage between the islands and it still may be blowing 20 knots, even though it's only supposed to be 15. The gradient wind was supposed to be 15, but it's blowing from the east. And now we move toward the northwest coast of St. Lucia, and we get wind backing to the northeast, but it's still 20 knots. But then we get behind St. Lucia and the wind drops below 10 again. So what's happening here is that all of the air molecules are being compressed and funneling between the islands, and it's causing the wind to be stronger than the gradient wind strength, and it's causing the wind direction to vary gradually as we make our passage across the channel between Martinique and St. Lucia. So in order for me to tell you exactly what the wind speed and direction is, I have to know, I could tell you what the wind speed and direction is where you are right now, but it's going to change as you move a few hundred yards or a mile or two because the topography is changing and the relationship between the islands is changing. So what we do in the East Caribbean is we point this out and we say that the gradient wind is going to be, east at 15 gusting 20. And then that between the islands, it's going to be 20 gusting 25. And it's going to be southeast near the south end of the island, northeast near the north end of the island. And you just know that because it does that around every island in the East Caribbean every day. Now, sometimes when we get something, really strong winds, we will just reinforce that because the impact of being out there in 20 gusting 25 versus 15 gusting 20, that's not a big impact. But let's say that the gradient winds are now 25 and, even during the day when it's not squally, it's going to be, gradient winds of 25 gusting 30. But if we add, let's say 33% to that wind, Now we've got wind in the low 30s gusting toward 40 instead of 25 gusting 30. So let's say that we're going to add 33% to the wind. The wind is 15. In between the islands, it's going to be 20. But now the wind is 25. We're still going to add a third to the wind. Now the wind is up into the low 30s and it's gusting 40. So, and that's a much bigger impact with much bigger seas as a result. So it's a much more significant weather event. So sometimes when it's real strong trades, we'll just point out that, hey, between the islands, it's going to be really, really strong, and you probably don't want to go out today. In addition, when choosing an anchorage, the waves will bend around the island. So let's say that we're looking at a landmass here, the edge of an island, and the wind is blowing in this direction, kind of from what would look like the southwest to the northeast. So the waves are going to actually bend around the island and back into the anchorage. So if I were looking at this on a chart, I might think, oh, well, I'll just anchor right in here in the lee of the land. I'll be out of the wind. I'll be good. But the wind may bend around the island, and certainly the waves are going to bend around the island, and that's just going to be a miserable anchorage. So maybe we want to go another mile or two and anchor well away from that point of land, or even 5 or 10 miles, depending on the size of the land and the bathymetry of the bottom. We want to make sure that we get far enough away from that point of land that we're not getting confused seas. Sometimes if we have a small enough island, we can get confused seas from both directions that meet in the middle and create a horrible washing machine effect. And, that may be worse than just anchoring out where you've got, the wind and the seas from a somewhat different direction and it's somewhat uncomfortable. Anchoring in this washing machine effect might actually be worse. Maybe there's a little nook in here where you can anchor in this area, and this little island helps break up some of that wave action. So you might have to do, trial and error to find a place to anchor here, but just realize that that can happen with air bending around and seas bending around the islands. Something we'll often get in the East Caribbean is a northerly swell. And what you are seeing in the wave product, if you're looking at a graphical wave forecast, or if you're using any sort of a wave forecast in general, it's going to give you the significant wave. And the significant wave is the largest wave. And so let's say that in St. Vincent, the largest wave is out of the east-northeast. And that's because we've got about 12 or 15 knots of east-northeast wind today. And if you're just in the lee of the island, the wave is going to be out of that direction, and you won't really be seeing the northerly swell maybe. But out away from the islands, both to the east and to the west, notice that the waves are coming in out of the north. In actuality, the waves are coming from two directions. In every place in the East Caribbean, we've got a northerly wave and an east-northeasterly wave, because there's an east-northeasterly wind on this day, and that's driving an east-northeasterly wind-driven chop. But the reason it's not showing up, let's say northeast of Guadeloupe, where we've got that sea coming down from the north, the reason the east-northeasterly sea isn't showing up is because the northerly swell is larger, and this only displays the largest wave. So we need to understand and incorporate, do some thinking and incorporate on our own, generate our own forecast, and know that there's a north swell that in the northern Leewards and the Virgins is actually a northwesterly swell. But as it gets down into further south in the Leewards and the Windwards, it's more of a northerly swell. But there's also going to be an east-northeasterly wind-driven wave. And we can guess what that is based on the wind speed. Let's say a 15-knot wind is going to drive a 4-foot east-northeasterly wave. And even in the areas where it's showing only the east-northeasterly wave, there's still a northerly swell. It's just the east-northeasterly wave is larger. So that's what it shows. So unless you're looking at a whole spectral wave forecast, which shows you all the waves individually, you would need to just do some thinking and realize that if you're getting waves propagating toward your location, even if the wave forecast for your location doesn't show it, the waves propagating toward you are going to get to you, and you'll need to incorporate that into the forecast. So our weather forecasts do incorporate that. Here's a little tip. Wind tends to be lighter in direction when it's backing and stronger in direction when it is veering. And this may be associated with the transport of warm, moist air, which tends to be a little faster, maybe. But in the northern hemisphere, at least, when the wind tends to veer from the northeast to the east, or the east to the southeast, or the southeast to the south, or what have you, that veering wind tends to be stronger. The backing wind from, the southeast to the east, or the east to the northeast, that tends to be a little lighter. So if you're going to get wind in any sort of a diurnal pattern that's shifting back and forth in direction, it's going to tend to be a little stronger when it's veering and a little lighter when it's backing. So I just want to use our remaining time to go through some strategies in the rest of the Caribbean and talk a little bit about what you might see in various passes in the Caribbean. In the Mona Passage, we can have a wind shadow from Puerto Rico. And what we want is to go from, let's say, the northeast coast of the Dominican Republic. Let's say we're in Samaná in the Dominican Republic and we're heading to Boquerón, Puerto Rico, Puerto Real, Puerto Rico. That's a pretty typical route to travel. It's about 150 miles. So you can do it in about 24 hours. Maybe it's a little less than 150 miles, but for most folks, it's, close to 24 hours. What we would typically want to do is leave the Samaná area along the Dominican Republic in the late afternoon, very late afternoon, right before sunset. Why do we want to do that? Well, remember, the katabatic wind is coming off the land at night. So we're going to get this calming effect near the land at night. We're not going to be bashing into these easterly trade winds, which we see are blowing 15 to 20 knots. At night, the wind is going to be east or somewhat southeast, so it may be on the nose, but it's probably only going to be about 10 knots, and the seas are going to be about 2 or 3 feet instead of 4 to 6. And, it's all kind of right on the nose, so I'd rather have 2 to 3 feet on the nose than 4 to 6 feet right on the nose. As we get out into the Mona Passage, if the wind direction is east-southeast, unfortunately, it's on the nose. The good news is that the island of Puerto Rico is blocking the wind. So there's a wind shadow that's cast from Puerto Rico to Hourglass Shoal and the northeast coast of the Dominican Republic if the wind direction is east-southeast. And so this wind direction has to be just right. But if the wind direction is just right, even though the gradient wind is 15 to 20, we can motor into 10 knots of wind all day during the daylight hours from the northeast tip of the Dominican Republic toward Puerto Real, Boquerón, Puerto Rico in calm conditions. Now at night, kind of the opposite happens. In the Mona Passage at night, the land breeze comes off Puerto Rico and that increases the wind across the Mona. It drops the wind along the north coast of the DR, but it increases the wind in the Mona. So at night, we're going to see, particularly in the evening hours, wind 20 gusting 25 out of the east in the Mona. So we don't want to be in the Mona at night because we get that wind coming off of Puerto Rico in a big rush of air. We want to be just getting into Boquerón around sunset. So that's the probably ideal strategy for doing Samana to Boca Raton, Puerto Rico. On the other hand, if you're trying to sail downwind and you want some wind for sailing, you're going to want to be in the Mona at night when there's some wind for sailing, and you're going to want to avoid the Mona during the day when there's no wind. And conversely, you're going to want to be north of the Dominican Republic during the day when there is wind, rather than at night where there's not wind. So just remember that if you're trying to go along an island to windward, fighting the trade winds, you want to be going along the island, fighting the trade winds at night when you get the katabatic winds coming off the land, giving you a calming effect. If the wind direction is not somewhat east-southeast between Puerto Rico and the Dominican Republic, this is what happens. It's a funneling effect. And you would think that maybe you're going to get some nice sailing with a nice northeast wind between the Dominican Republic and Puerto Rico, but it usually doesn't work out that way. So the problem here is that the wind that's near 15 knots north of the Dominican Republic and north of Puerto Rico, this wind, just north of the Mona is northeast at about 15 or 17 knots. It turns into northeast at 20, gusting 25 or so in the Mona because it funnels faster through this compressed area. So if you get a day that you think looks good for sailing on a close reach with northeast winds at 15, it's probably going to be a closer reach than you really want between the Dominican Republic and Puerto Rico, and it's probably going to be 20 plus, and the seas get really big and confused and messy because of all the bottom contours, and it's just really messy. So you probably don't want to do eastbound from the Dominican Republic to Puerto Rico. Even if the wind forecast is northeast at 15, you'd much prefer east-southeast wind right on the nose when you can be in the wind shadow of Puerto Rico crossing the Mona. Let's say that you are in the Windward Passage, south of the southern Bahamas, between Haiti and Cuba, and there's Jamaica. So maybe you're heading through the through the Windward Passage to get to Jamaica, or maybe you're heading west along the south coast of Haiti to get to Jamaica. There's a lot of land effect that happens here, and it's a diurnal pattern. So this is a Grib Explorer, and it shows us this diurnal pattern really, really well. Notice that around zeros, and my cursor is, I don't think I highlighted where my cursor is, but it's right at 20 north and about 73.45 west. So my cursor is right, right here. Notice that in the middle of the Windward Passage there, on this first day, we've got persistently strong winds, pretty much 20 knots the whole day. But as we get into the night of the 4th and the day of the 5th and the night of the 6th and the day of the 7th, or the day of the 6th, the next couple of days, there's a really pronounced diurnal pattern with almost no wind in the late morning to early afternoon, and then really strong wind, 20 gusting 25 plus, out of the northeast or east-northeast in the late afternoon and evening. And this is a land breeze sea breeze effect, and it's funneling through the Windward Passage. So the trick in the Windward Passage is, if you're looking for relatively benign conditions, pretty much regardless of what the wind is, you want to make sure that your timing is between about 20 and 19 north, where we get this biggest funneling effect. You want to make sure that you transit between 19 and 20 north in the late overnight, morning, midday, and early afternoon hours. And you want to be either north of 20 north or south of 19 north before the very late afternoon, when the wind really starts to crank. Now, the wind direction also is an on-off switch. So what happens as we get into this time frame, and this is the the 6th into the 7th, notice the wind just kind of goes away. Well, this is the graphic for the 6th into the 7th. The gradient wind didn't go away. All that changed is the gradient wind direction. So notice north of the Dominican Republic here, we have an east-northeasterly trade wind flow. North of the Dominican Republic here, we have an east-southeasterly or an easterly trade wind flow. That puts the areas west of Haiti into a wind shadow and completely kills the wind. So there's no wind in the day, there's no wind at night, there's no wind at all west of Haiti into the Windward Passage if the wind direction is somewhat south of east. So if you're looking for a really calm transit of the Windward Passage, wait until the wind direction is a little bit south of east, and then there won't be any wind at all. Almost guaranteed. This is a little bit of a wind paralleling the land effect. This is Cabo Beata, the south coast of the Dominican Republic. Notice that we've got 15 to 20 knots of easterly wind if we get offshore, but near the coast it's a northeast wind on the north side, on the east side rather of Cabo Beata, and on the west side of Cabo Beata is a somewhat lighter and a southeasterly flow. And around the Cape it tends to be a stronger flow. And we can see that even better here. On this day, we showed more of a compression zone with wind above 20 knots in compression within about 100 miles south of the Cape. So anywhere where there's a cape that restricts the flow of air molecules, you want to appreciate that there's probably going to be more wind there, and there's probably going to be somewhat more wind than your computer model predicts, and the wind is going to tend to parallel the land. There will be stronger wind on the windward side of the peninsula and lighter wind on the western side of the peninsula because the wind doesn't remain attached to the land on the downwind side of the peninsula. So let's say that there's a trough around and that you're trying to discern where the bad weather is going to be relative to the trough. The intertropical convergence zone is a good example of a trough, and it's a good example of where we can find the bad weather associated with a trough. So the bad weather is going to typically occur on the surface convergence side of the trough. And how do we tell which side that is? Well, basically it's the windy side of the trough. And the weather on that side of the trough is probably going to be worse than computer models predict. So this is an example of the Southwest Caribbean. Here's Panama, Colombia, Nicaragua. And this is the northern boundary of the intertropical convergence zone. Notice that in the offshore waters of the Central Caribbean, wind is really, really steady. It's straight out of the east at about 20 or 21 knots. As we get into the convergence on the north side of the ITCZ, the wind speeds are still, mostly around 20 or 21 or 22 knots. It's all, roughly the same wind speed, but the color shading is precipitation. And then as we get south of that northern boundary, once we get within the ITCZ, the wind really drops. It becomes kind of light and variable. So what happens is that along this interface between no wind to the south and steady trade winds to the north, we get air molecules interacting with each other and forcing air upward in the atmosphere that generates lift, convection, thunderstorms. And typically in this band, we're going to have steady wind in the 20 to 30 range and squalls and thunderstorms in the 30 to 40 range. The computer models don't really pick up on it, but it's almost certainly going to happen. So realize that if you're looking at, and this gets into more of a forecasting symposium, and this isn't really a forecasting symposium, but whenever the wind isn't steady from a steady speed and direction, something has to make the wind change. And we need to understand the mechanism that makes the wind change, and then we can incorporate that into the forecast. And what's going on here is there's a trough. It's the northern boundary of the ITCZ. It's going to be squally. It's going to be windy. And even though the computer model doesn't really show it, and if we weren't looking at precipitation, we would have no idea, except that, the wind goes from light and variable here to east at 20 there. We would have no idea that this is really a trough unless we were looking at the pressure isobars or the precipitation. A little bit about Santa Marta. So Santa Marta is right in here along the Colombian coast. And Jimmy Cornell mentions that Santa Marta is one of the 10 most treacherous passages in the world. From Aruba to Cartagena in Panama, you've got to go by Santa Marta. But there's a trick that if you know the trick, it's really not treacherous. And so the problem that happens is if we were looking at a topographical map, and if I took the color shading off here, you could see the topographical map. Right in here are the Sierra Nevada mountains. They're about 20 or 30 miles from the coast, and they're just southeast of Santa Marta. They're southeast of the Cape at Santa Marta, and basically east of the marina and bay here at Santa Marta. And those Sierra Nevada mountains are 20,000 feet high. So you've got 20,000 foot mountains about 20 or 30 miles from the coast. And what happens is that during the daytime hours, the air blows from the east up the mountains, and not much happens. The air comes down the backside and doesn't really stay attached to the land, and there's no big problem. But at night, the easterly trade winds that are forced up 20,000 feet into the air, now those air molecules really never wanted to be at 20,000 feet into the air. The only thing that got them there was mechanical lifting. They had to go up the slope of the mountain. Some of the air molecules tried to go around the mountain, but most of them didn't succeed. Most of the air molecules are forced up over the top of the mountain. Those air molecules don't want to be at 20,000 feet. They want to be back at the sea surface, and they're going to get there like that. So if you actually look at the 850 millibar altitude winds, these would be the winds at a couple thousand feet. The wind forecast is correct at a couple of thousand feet, but what the global forecast models miss is that those winds are actually going to keep going all the way down to the surface of the ocean, and they are going to intersect with the ocean. And the global forecast models just can't resolve that. So, it's unfortunate, but it keeps us in business because we know that trick. And you don't want to travel in the area near Santa Marta and Barranquilla and Cartagena at night, because a 25 knot wind will turn into a 35 knot wind or more at night. You do want to transit that area during the day or when the winds are calm. So the two solutions would be you go from, well, you can time your passage from Aruba so that you're reaching the eastern side of the Cape at dawn and you're into the anchorage in the afternoon. That works very well as long as the trade winds aren't too strong. And then you can move early in the morning from the anchorage at Santa Marta to the marina at Barranquilla, Puerto Valero Marina at Barranquilla. That's up just in the mouth of the Rio Magdalena River. And then on the next day, you can go from Puerto Valero Marina to Cartagena. And so those are daytime hops that keep you out of that area at night when the katabatic wind's coming off the land. So just realize that this is a really treacherous area. If you play it wrong, communicate with us. We'll steer you right and keep you out of harm's way. Will Cape Forecast give you the information you need? Not in this area because it's not convective. This is not a convective wind, it's a downslope wind. If you were in Colorado dealing with downslope winds coming off of the Rocky Mountains, it's the same sort of a thing. So it's not really convective, it's due to terrain. And the computer models, the global models, have a really hard time resolving that terrain and generating a correct forecast. I don't want to get too long. We already kind of gone longer than I thought. Cuba. I do want to talk a little bit about weather in the Western Caribbean, the Northwest Caribbean. The Northwest Caribbean can be a really difficult place. There can be really profound diurnal patterns. This is the wind off of the Bay Islands of Honduras. And look at the diurnal pattern here. We've got, basically 30 knots of wind at night and, 15 or 20 knots during the days. And so the wind spikes, and it's the same sort of an effect of wind coming down off the mountains. We get an east-northeasterly trade wind flow in the afternoons that's fairly benign, maybe 10 or 15 or 20 knots. But then as soon as nighttime rolls around and the air starts coming down off the mountains, it switches to an east-southeasterly flow with air coming off the tall mountains of eastern Honduras into the Bay Islands area. And it turns into east-northeast veering east-southeast at maybe 30 gusting 40. So that can be really difficult, and it's governed by the wind direction and the strength of the gradient winds. So sometimes we see it and sometimes we don't see it, and it shifts around a little bit based on the wind direction and other things. So the forecast for the Northwest Caribbean is really, really tricky. Another thing we see is air paralleling the coasts. Let's say we get a cold front coming through, the trade winds are all out of the northeast. So you would think that with a northeast wind, a large scale gradient wind coming from Cuba from the northeast, you would think that the wind along the Yucatan, Mexico and Belize and Honduras and Nicaragua would all be out of the northeast, wouldn't you? Well, it isn't. Typically the wind coming down the Yucatan parallels the land, so it's out of the north or northeast along Mexico. So it's basically paralleling the land. And then we typically get a land breeze effect with air continuing to try to parallel the land along Belize and Honduras. Along Honduras, this manifests in a west component wind. And along Belize, we turn from a north wind in northern Belize to a northwest or west wind in southern Belize. And there's also some diurnal pattern here. Once the wind switches to the west, it tends to be much stronger at night in Belize and in the daytime in Honduras, because it takes a few hours to propagate east. And then, during the other part of the day, we'll tend to get lighter winds in the midday hours in Belize and maybe a northeast wind and an afternoon sea breeze. But in the Bay Islands of Honduras, the wind will just go light in the afternoon and evening and then fill back in out of the west in the morning and midday hours. So we just get a lot of, and along the coast of Nicaragua, the wind is north or a little north-northwest. And along Panama, it may be northwest, even though the gradient winds are northeast. So there's just a tremendous land effect in the Western Caribbean, and it makes the forecasting really, really challenging. I don't want to dissuade anyone from going to the West Caribbean. I mean, Panama is gorgeous. Colombia is wonderful. I hear great reports from folks in Colombia. Obviously, the COVID-19 thing is a bummer, but as soon as that's resolved, Colombia, I understand from almost everyone who's been there, is just an amazing place to go on your boat. And Panama has highs and lows, but much of Panama is terrific on both the Caribbean and the Pacific side. And then, Providencia and San Andreas, the offshore islands of the Southwest Caribbean, are also terrific. And the Caymans can be nice, and Jamaica can be nice, and Honduras and Belize have nice spots, as well as Mexico. So, lots of good cruising in this area. It's just that the weather can be a little challenging at times. Any questions? No questions at all? We got everyone? All right, you're very welcome. I didn't mean to quite take that long, but I hope you found the information useful.
Hey, Chris, it's Sheldon.
Yes, Sheldon.
Hey, if you would just real quick review your intentions the week before we head out. Over.
Sure. So the week before the Salty Dogs head out, typically you will get us the list of participants about a week, maybe 5 days before departure. And at that point, we'll get everyone loaded into our system with an account, and we will email you your account credentials. so that you can log into your account at mwxc.com. We will also start sending you the regional daily email forecasts immediately at that point, so that you've got our perspective on the large-scale weather pattern. And then and you're free to start participating in the single sideband nets and the webcasts that we do in the mornings and the evenings. A couple of days before departure, we will start doing dedicated Salty Dog webcasts sometime in the late afternoon, and Sheldon will announce exactly when we're going to do those, but it'll be starting a couple of days before departure, and it'll be just for the Salty Dogs on a webcast, and we'll show our computer screen like we're doing here. It's a somewhat different platform. We use Greenlight Collaboration instead of Zoom, but it's a similar experience. And so you'll be able to see our desktop and ask questions and cover all the details. Then let's say a day or so before departure, we'll start sending out the Salty Dog email forecast. And that is not a specific forecast just for your boat, but it's a general forecast for the fleet, and we'll kind of highlight where the vessels are grouped. And when you're underway, you'll continue getting the regional forecasts, which cover the whole region, but they're really only good for big picture stuff until you get to the islands. And then we'll send that Salty Dog email forecast that's going to cover the Salty Dogs, not your boat specifically, but we'll kind of try to identify where there are clusters of boats, and particularly keep you out of high impact weather events. Keep communicating with us on the single sideband radio nets when you're underway. If you don't have single sideband, and you need something more than just the Salty Dog email forecasts and the regional daily email forecasts, the next best thing for us is if you pick up the satellite phone and call us. If you pick up the satellite phone and call us, then we can figure out what you need really quickly, answer the question, and have any sort of a two-way discussion we need, and then we're both done and we can move on to other things. The last thing is if we, if you don't have a satellite phone and you need or strongly prefer to communicate by email, you can send me an email and we will answer the email or the inReach text. What's challenging with an email or an inReach text, and put yourself in our shoes for just a second. The first thing that we have to figure out is where you are, and are you a Salty Dog or are you one of our other clients? So if you can make sure you tell us where you are and identify yourself as a Salty Dog, that helps a lot. And then be really specific with what you need to know. Because the other thing we have to figure out after we figure out where you are and whether you're a Salty Dog or not is what is it that you're asking for? So be really specific with what you need help with. Do you need a forecast for tomorrow? Do you have an equipment problem on the boat that's preventing you from doing something? Do you have a specific concern? The more specific you are, the less we have to guess about what it is that you need, the quicker and better we can answer your question. One of the most frustrating things is we open up an email, you don't really tell us where you are and don't identify yourself as a Salty Dog. We spend time tracking you down, and then your email is just really general. Like, what should I do next Tuesday in the waters off the northern Bahamas? Well, I don't know. Are you heading to the Bahamas? Are you considering diverting somewhere? Be really specific with why you're asking the question and what you need the information for, so that we can help not only provide the information, but coach you to make the right decisions. Because ultimately that's what we're here for, is to help coach you to make the right decisions based on what the weather's going to do. And the only thing that isn't covered is a specific email forecast just for you. So those take us a long time to generate. But if you want, a specific email forecast just for you from point A to point B, that covers, 5 days, that's going to take us an hour to generate. And we'll have to charge you for that. That isn't part of the Salty Dog Rally. So Sheldon,
So,
is that it?
yeah, no, Chris, thank you very much for that little update for everyone to understand what they're going to be getting. We're going to have probably 65% of the votes are brand new. They've never gone out and done this before with us. So it's very exciting for so many of our people and myself helping
Great.
to lead them along this thing. To give everyone an idea, one of the things Chris will be providing you based on storms, based on fronts, different things that are happening, he may say, do not go south of 22 degrees. He may say, do not go south of 18, whatever the case might be. Do not go east of this because there is a storm. And so he's looking at these things to try and guide a group of boats, which typically if we all leave about the same time and we're going down to the Bahamas or we're going down to Antigua, we typically are, within 20 miles of each other, whatever. And Chris is able to look at that and put those things together. But at the same time, if you go back to Chris on single sideband, or you give him a call and you say, Chris, this is Sheldon, I'm on my catamaran, and you told me not to go south, and I'm an accomplished sailor and I can do this and that. What do you think? Is it really that dangerous? So what Chris told me last year was, Sheldon, come on, you can make it. A lot of the monohulls will not be able to make it, but go for it. You'll be okay if you think you can do it in this many hours. So he gave me a time scale, and Chris was right. We got in there. Yeah, it was a little bit rough making the passage south of what he told everybody to stay north of, but it really did work. So those are the kinds of things that Chris is going to provide. He's giving us these forecasts. He's providing a forecast for the majority of the boats. Now, I will tell you, the one time we went out and Chris is sending out his forecast. And of course, me on Perfect View, I'm doing my own thing. And I thought I kind of understood the weather pretty good. And I took off and made my own passage, doing more of a rum line than what Chris was telling me. And I had to send him a message, say, Chris, I'm down here by myself. And he goes, oh, what are you doing down there? You're supposed to be with everybody else. But he guided me along and got us to where we had to be. So if you have any further questions, please real quick get them in, because we're taking up a lot of time. Chris would be writing things for other people. But Chris, this was great. I really appreciate what you've done and the time you spent with us. This is really helpful for everybody, I think. So
Terrific.
there's no other questions. I don't see anything coming in. Oh, here's thanks from Jessica. Okay. All right,
Thanks,
Chris,
Jessica.
thanks so much. And this has been fantastic. We're going to sign off and
Okay.
appreciate everybody's time.
All right. Take care.
Thank you, Chris.